is composed of a magnet that is attached to a float and a circular compass card that displays your heading in degrees. The float rests on a pivot assembly which allows it to rotate freely. These components are housed inside a case that is filled with kerosene-like liquid to dampen out the shakes. This is Earth and a near representation of its lines of magnetic force. Around the equator, these lines are parallel to the surface of the Earth. The magnet has a tendency to align itself with these lines, so around the equator the compass is level. But at 40 degrees south, for example, the magnetic lines dip towards the South Pole. The magnet aligns itself with the lines, which are no longer parallel to the surface of the Earth, resulting in the dip that causes the magnet's centre of gravity to shift towards the north. So when you accelerate on an easterly heading, the centre of gravity, due to its inertia, resists to accelerate with you, causing the compass to indicate an apparent turn to the south. Once you establish your speed, the compass realigns itself. When decelerating, the centre of gravity advances, causing the compass to indicate an apparent turn to the north. Similarly, when you accelerate on a westerly heading, the inertia of the centre of gravity resists, causing the compass to indicate an apparent turn to the south. Once you establish your speed, the compass realigns. When decelerating, the centre of gravity tends to advance, causing the compass to indicate an apparent turn to the north. Accelerating or decelerating on northerly or southerly headings does not cause errors since the centre of gravity and the pivot point are aligned with your heading. Remember these mnemonics. Use ANS in Northern Hemisphere and SAND in Southern Hemisphere. We will discuss magnetic compass turning errors in the next video on this subject.